does fail, that we're gonna get a failure right here near the thread on the back or the front, and that's because of the stress concentration. What kind of thread did you use? Is it a sharp tooth thread?
Well, it's a truncated thread. It's a fine thread.
Hopefully it won't, but if it does, we're gonna get some great high speed, hence the Lexan. There we go.
Yep.
I think it broke where I thought it would. Yep, my engineering professor didn't lie to me. Have you ever seen that?
I've never seen that. I've never seen anybody do that before. I've never seen anybody do that. Mumford people.
What's Mumford people?
Mumford, USA. Mumford, Alabama. Mumford, USA.
I don't understand the reference.
We be rednecks.
But we designing stuff. The fact that it came off had to do with axial stress. Like once it pressurized that tube, it's pulling the whole can. And those threads just couldn't handle that, right?
That's right.
Okay, so the one we're about to do is something you actually sell.
That's right.
And you've never seen it like this.
Never have.
Okay, cool. So this is a 223, and the idea here is to contain the gases in the back and then stop it from exiting with that diamond pattern in the front.
Fire and hole. Fire and hole.
So if you think about what this suppressor is doing, there's two stages to it. The first one is the capture of the gases on the inside, this expansion volume. And then there's this restriction to flow to keep those gases inside the can so you don't let them flow out.
All right. Fire and hole.
Steve didn't tell me is that this was one of the first conceptual designs Soteria made back before they had done much research. He also didn't tell me that he had no intentions of shooting this one, so he made it out of thinner acrylic as a display piece.
It's got like this claw built into it, and that claw kind of looks like it's going to grab some of that gas and not let it go. So I'm pretty pumped about that. You ready? Ready to fire.
Full disclosure. Fire and hole.
There it went. Why did you tell me?
I did. I said full disclosure, and you went on with the test anyway.
He jinxed us. Because
I said it was my favorite.
He said, I love this. It's because this one's got claws.
It's my favorite design, and you knew it was gonna. How did you know it was gonna fail? In all seriousness.
Actually, well, it was a smaller diameter on that 308. It works well on the 223, but on the 308, we need more capacity than that. That's a 35 millimeter suppressor. It needs to be like a 41 millimeter.
This is a developmental test, so let's see what we can learn. Instead of using a segmented baffle system, this type of suppressor uses a monocore design so it can be easily cleaned in the field. We fired another round through the monocore without containment so we could see exactly what was happening. As you can see, these flat parts are flexing out from the inside and they're pushing on the inside of the sleeve, causing a localized stress concentration. This is called destructive testing, and it's my favorite part of engineering. Steve obviously knew this was going to break. If we used a metal can, this wouldn't have shattered. But what he did is he weakened one part of the system so that we could see how strong the other components were. Once you figure that out, you can figure out how to tweak your design, and you can make a really strong overall product without making it too bulky. This is really smart, and it's something that engineers do all the time, and it's one of my favorite things in engineering.